Good afternoon, or morning, or it's that time of day, isn't it? You all having a good time so far? Yes. All right, good. So who's ready for some more Angular? All right, you're feeling a little sleepy, aren't you? I'll have to wake you up a little bit. So today's talk, when I was talking with the event coordinators, I wanted to do something a little bit different and talk about the ecosystem around Angular. And the title of this talk is Less Servers for Your Angular Apps. But I want you to first think about, when you're building applications, it's never just Angular. I often am quoted as saying, the hardest part about Angular is not Angular. It's the stuff around it. Angular is relatively easy and smooth to use. It's the pieces around it that you have to do to build an entire application. So today I want to talk about how we build applications and the assumptions that we have in those applications when it comes to servers. So we're going to challenge our assumptions today. All the things that we just live by day, and how we build our web applications. So the questions we should be asking, first of all, are static assets, HTML, CSS, JavaScript, images, fonts, all those things, are they the same type of content as a web API, as data being served off a server? When we serve static assets, are they the same concerns and things that we have to deal with when we deal with a web API that we might build with Node or ASP.NET, for example? And if you agree with me that there's different things you have to do for getting your data versus getting your static assets, and there's a different number of calls you make for your applications, what is the maintenance and the load on those servers? And that could be anything. That could be the physical cost, how much money it takes, how many servers you have to prepare. What do you have to do to make sure Node or ASP.NET is actually running on your servers? How do you patch them? What about security? All the different things you have to do with your servers. How do you scale up or scale down? All these things have to come into play. And the difference between a static server and a web API is very different. For example, if you build a very public web API, website, out in the web that has millions of users hitting it, the static assets get hit for that first page once with Angular, right? Most of them come once, unless you're lazy loading a couple other times. But your web APIs will get hit a little bit more than once on your application. And there's different things that actually happen to it, so the loads are different. And then when you build a real enterprise application, you generally have more than one environment as well. Do you have dev, test, staging, prod, load? You have all these different environments. Now you need multiple servers. And let's say you just have one server. You're a smaller shop. You just have prod. You go from dev to prod. God bless you. Let's say you just have one of those. Sometimes you need to scale up or scale down, so you need multiple servers to handle the load as well. So how many servers do you need? I've worked in shops where we had 7 environments, and we had to scale out to 10 servers in the production one. You start doing the math, and even at a couple bucks a server, those things add up. So there's a lot of things to think about, not just the cost, but the maintenance on them all, keeping them in sync. And then, of course, you're running Windows 10, I'm running Mac, you're running Linux. You all build it works locally on your machines, but then you go to production, you don't know what you're running. You're in CI, you don't know what you're running, so you have to make sure these things are all into account. This is real-world stuff, right? And it has nothing to do with Angular. You want to get your Angular running in the cloud, you're like, it works on my laptop, can I go home? And that's where I am. So let's explore first what I'm talking about with this. You've got, let's say, a Node Express server. We could pick ASP.NET, PHP, Java, whatever. Let's say we have a Node Express server, and we want to see what it takes and how we can actually deploy an Angular app with it. So with that, we'll walk through Angular using TypeScript and Node.js on an Express server. So in this application, and I like to point out a couple times during the talk that everything I do today, you'll be able to try. All the GitHub repos, there's an article explaining how to actually do all this. There's 2 tutorials that you can walk through. And if you want to deploy it to Azure, there's a link that you can go to get a free account as well, so you can try that. So everything you need, I'll give you resources at the end. But in this application here, I've got, and we'll zoom in over on the left, I've got my Angular app right there in my source folder. And then I've got my app, and I've got heroes and villains. Hey, guess what? John Papa did a Tour of Heroes demo. So everything in here is running for my heroes, my villains, inside of Angular, and then I have to hit a server. So I've got a server folder right here. And my server folder is running Express. If I come down and look at my server, You can see in there I've got Express and body parser, and in a full-blown enterprise app, I probably have about another 20 middleware options in there as well for logging and security, maybe Luska or Helmet for that. And then I've got my function right here that just kicks everything off, checks for environment variables, loads up my routes, loads my HTML and my static assets. Everything looks pretty good to go. And then inside my services and routes folders, that's where I'm holding on to my routes themselves, like heroes. When I see, hey, you got /heroes, go call my service in Express that says heroes.getHeroes. So I come down to that one, and now you can see I've got my async function for getting heroes, and I'm using TypeScript, which, by the way, is really awesome for Node Express, because now I can actually get all the types for my request and response objects. And then I can go ahead and make my call out to my database and return my response however I want to. So all this is running through Express, and it works just fine. Now, no app is real unless we can actually run it and debug it. So I've got a bunch of debug configurations up here. These are also in the article that I'm going to point at the end, so you can see how to set these up. But the debug configuration I'm going to show you is, let's debug Express and Angular at the same time. So I'm going to select that one here. I'll show you over here kind of what that does. There's something called a compound inside of VS Code. I debug Express and Angular, and it points to two different debug configurations. These are the same names that you'd find up here. So there's my launch Angular configuration, which, if you don't know how to get that, I'm going to show you how easy it is to type that whole thing. A-launch Chrome. If you've got the Angular snippets, it just kind of types it in for you. And you can also do it for Edge if you're using Edge as well. We've also got our Express debugging right there too. So all that is set up for us. Now I can just press this button, zoom back out. That's what happens when you delete something. I just deleted my launch configuration. There it is. Now we press green button. And what it's doing is cranking up a couple of things. It's cranking up the debugger for Express, so it's building my Express app, and then it's going to hook to it and debug it. And then it's also building my Angular application. And then once it builds the Angular application, it's going to serve it and open it up inside the browser. Now you can see the debugger is already starting up here on the top of my screen. It's going to look a little bit different when it's done. That's because there'll be two configurations for debugging for my application. So here's my app, my tour of heroes. And then over here in my debugger, we can see that I can debug either Node Express or Angular. Now, you don't have to select one or the other. It actually does it for you. But you'll see, if I go enable my breakpoints, I flip back to the app itself, and I refresh. I'm now hitting a breakpoint inside my Angular application. And then I press run, and now I'm hitting a breakpoint inside my Node Express application. It automatically toggles between the two. You can step, go into it, jump over it, anything you'd like to do. So the nice thing about this is now I've got my Node Express app that I can debug locally on my machine. And if I want to deploy it, I can deploy it two different ways that I really enjoy. One is what we call loose files. We can just take the files themselves from the builds and then copy them up to a server in the cloud, or go through GitHub through a CI process and then push them to a cloud. I'm not as huge of a fan of that as I used to be, and I'll tell you why. I've been burnt by this a lot. I'm building on my Mac here. It goes to my CI machine. My CI machine's running Linux, slightly different, right? All of a sudden, somebody upgrades from Node 10 to Node 12 on the CI machine, and they start pushing to production, and it breaks. Things aren't working. Now you've got 10 apps, 20 apps, 30 apps, and that can break. So what I like to make sure is that the environment I have on my machine, when it works everywhere. So I like to use Docker to do this exact thing. And in this same repo, once I destroy the debuggers, there we go, you'll also see there's a Docker file in here. And the Docker file is set up so we can both build the Angular application. It does everything you would do normally, basically npm install and then an ng build prod. And then it goes out and gets whatever version of Node I want, does an npm install. I'm using TypeScript, so I transpile my TypeScript for Node with Express as well. And then I take the final results and I push them up into a container. And now I have this Docker extension over here in VS Code, which you can download. And what I do is I just build it, and I'm just going to start it up because it's already on my machine, just so we don't have to watch it build. And now you can see it's running on port 7070 right there. And if I go back to the browser, and let's go ahead and open a new window. And there it's running in Docker. Don't believe me? We can go in over here and debug it. We can now say Docker attached to Node right up there in the debug window. And I think I left my breakpoints on, so now if I refresh, it's not hitting. Oh, it didn't start. You actually have to hit the green button. VS Code likes it when you actually tell it what to do. And there you go. So now we're debugging it again through VS Code inside of Docker. So I like the debug steps because it makes sure that everything runs the same everywhere you are. Now, let me get out of this mode for a minute. The reason we kind of went down this path is to say, when we build these applications, this is kind of the traditional way we've been building it with the server and a client. Now imagine I take this Node server and I have to deploy it out with multiple instances of the server with a load balancer on top so everybody can hit it. Maybe I've got a light and dark mode or an A/B mode so I can make sure I can put new things in. The Azure terms for this are like slots. You have one version of the site now, you want to put another version in later. This stuff can really add to the maintenance of what you have to do because you might need multiple servers. And what if you have multiple environments? Well, all we're really doing on the server is serving the assets and using a web API. So let's think about this architecture. Often, we're envisioning this when we run into projects. Like every time I go to a new project, I'm thinking, that's how it's going to work. I got a web browser, I've got a back end, it could be .NET, Java, Node, whatever, and I'm hitting a database. That's usually what happens when somebody talks to me and goes, John, I've got this problem, help me build this app. And usually, it looks more like this when I end up going to it. They're like, oh yeah, we're actually hitting these other back ends with different databases. Sometimes we get HTML, sometimes it's XML, sometimes it's fixed length format, and oh, this one over here is JSON. And I'm like, yes, one of them is JSON. And then they're like, but yeah, that JSON's like 10 meg of data. It's like, oh man, real world, you know? Well, then you start thinking about, can I change my back end? The budget for the project is to build an Angular app. You're an Angular developer. You're hired to build with the Angular app. You're not building the Java, .NET, and Node apps. And there may not even be budget or time to do that. How many of you here work under budget and time constraints? Nobody, right? Yeah. So when you have those issues, what do? There's numerous calls, large data, lots of different things going on. I like this pattern I call the presentation API. So let me show that one more time. We've got the web browser and our back ends. All we're doing is shifting this thing called a presentation API in between the back ends and the front ends. Now, this is an extra layer, yes, but it's super fast. What is super fast at input and output? I wish we had a technology like that. Node is great at that. So Node's one thing. ASP.NET Core is another thing you could use in there. You like Go, you can go that route. This presentation API's purpose in life is to aggregate the data, to make the bunch of calls for you. Because what happens if you don't have that presentation API and you make those 4 calls or the 5 calls from the web browser and you're on slow Wi-Fi? Are you going to let the browser make all those HTTP calls, aggregate the data, try to transform your XML into JSON, merge multiple JSON sets together just to show username John Papa? I've seen that, especially on mobile devices. That's killer. So the presentation API can do that aggregation. It can add a layer of security. It can transform the data. It can reduce the data. It can do all those things for you, or it can make database calls directly if there's new things. Think of this as an API for your UI. So now we've shifted the web APIs to a different place. This is what Angular sees. When you go develop with Angular now, you can say, you know what? I can even mock out that presentation API and use what I need right from there. Because I love to mock out my APIs, so then I can just build the UIs that make sense for me and my team. So we talked about Node and Express as a server. But now we're talking about, okay, we just went to building a presentation API. What if instead of Node and Express as the presentation API, we used serverless? Something like Lambda or Azure Functions or Google Cloud Functions. We can use serverless to do the same thing, and now we don't have to have a physical server that we deploy to, because serverless is built to scale up and scale down as we need, and we don't have to worry about setting up an actual server. If we go back to that diagram, we have a web server still too. Don't we need a server for that? Well, if we move the APIs over to serverless, now we just need to serve HTML, CSS, and JavaScript. Well, do we have anything in the web that can serve static assets? Absolutely. We have storage and we have CDNs. And they do these really, really well. So now you're taking your static assets, serving them from storage, any kind of storage container in the cloud. You could attach a CDN if you desire. And then you can serve those assets from there. You can serve your presentation APIs from serverless functions, and guess what happens to all your servers? Poof. It's serverless. So do you always need servers? And the serverless term is interesting because it doesn't mean you don't have servers. It just means that you think about them less. Somebody else is managing those for you. So doing this, you can reduce a lot of the maintenance, a lot of that load, and you still get quite a bit of the benefits in the process. You also have security benefits, too. Have you ever had a server in the cloud where you had to put patches on it with VMs? Or you want to make sure someone else is doing it for you? Well, with serverless, these things are automatically handled for you. So a lot of ways you don't have to worry about them. Also, any code you write, you don't have to worry as much more about these kinds of hacking. And it also will scale up and scale down for you. And you can put on different kind of notifiers and logging to determine what's happening to your server at the same time. Super high performance with serverless as well. This is great for things like when you have like a Black Friday sale. You always hear about these sites that are kicking into things like serverless and scaling up and scaling down. You get really fast performance, you get high scalability, and the cost, if you pick a consumption model with serverless with any of the major cloud providers, you only pay for when you're actually running the functions. That's it. Whereas when you buy servers, you're paying for the server whether you're using it or not. So you may have heard this term before. It's called the JAMstack. The JAMstack is one implementation of how to do this. I like to call it serverless web apps. JAMstack is cooler, but I'm just not that cool. So serverless web apps, serverless for the functions themselves. I don't actually have to serve the static assets, and they are web apps, right? They're Angular. So with serverless web apps, the JAMstack, what they stand for, J is for the JavaScript. We've got that. APIs, we've got that too with our serverless technology. And our markup, we've got that as well. So all these things put together help us build our serverless web apps. Now, we're here for Angular, so what could this look like for Angular? Well, here's the real surprise. It could work for Angular, for React, for Vue, or for Backbone, if you prefer, in your application. So remember, this is what Angular sees. We talked about if we're using Node and Express in this case, our web server could be serving from Node Express, so could our presentation API. Now, if we go another direction, with the storage, we could actually use storage to serve the static assets. So now, presentation API is serverless, storage is running our static assets, and Angular is just looking at our storage assets to load up the web browser, to see our content, and then it hits the functions whenever it needs to get its data. So let's see a demo with the same application on how this could work. We're going to walk through a little bit of the Angular code, which doesn't change at all in this case, other than where it's pointing for its APIs. We're going to look at the TypeScript, obviously, both on client and server, because the serverless functions, you can use TypeScript. You don't have to. You can choose JavaScript or C# or whatever else you want, or Python. But we can use TypeScript. This way we can stay in TypeScript on the client and the server. We can see how storage works in uploading our files. And of course, we'll take a look at serverless. And I'll be using Azure Functions inside of VS Code. So here is our same application. I'm going to disable the breakpoints again. And we'll take another exploration over here at the application itself. Remember, we have this server, but we don't want to use that. We want to use Azure Functions. So I've got an Azure Functions project over here. How did I get that? Well, the really cool thing about the Azure Functions extension is that you can literally come over to Azure Functions over here, and you can click one of these icons. I'll show you what they do. This one here creates a new project. That one creates a new function. And that one, which looks like it's pointing at the ceiling, because that's where Azure is, that's deploying the function app. So if you want to actually deploy it. But you can run the Azure function app right on your machine without even talking to the cloud. So don't worry about Wi-Fi inside the conference center. You can actually try it. So once you create that project, I put it inside this folder, and then every function basically gets its own folder. And I named these kind of overly explicit to show what they are. I've got my heroes get function, and there's two files. There's a function JSON, which is configuration for the function. And it shows how you can set up this function itself. And the only thing I changed was line 10. The rest of the lines got set up for me. I could set up authorization if I wanted to, other methods. And in this case, I wanted the route to be called heroes. I don't want it to be called heroes-get. That's just the name of the folder it's in. And the function itself is this. So the function, and it generates this code for you, all you have to do is fill in line 5. So line 5 is, what do you want me to do when I get this route? When you go to API/heroes, what happens? Well, here's the cool part. I wrote this project over in Node and Express. So when I go look at my Node Express app, here's my hero service for Node Express. Let me open up the hero service for functions. Look similar? It is literally copy and paste except for 2 things. Line 1, Express. That's where I'm getting request and response. Line 1 on the other side, go get this context object from Azure Functions. Well, then you're thinking, wow, what's that other thing? The other thing here is, well, yep, I got request and response on the left, but on the right, I just used destructuring to get request and response out of context. So I copied the files over that I wrote in Express with TypeScript, put them over in the functions, made 2 changes, which is super fast to do, and then I can run my functions app. So let's take a look at this. Now, this app happens to run against both, so I'm going to run a different port just to be explicit. My functions app runs against port 7071, and the Express app runs against the 7070. So we'll run that here. We've got another debug configuration up here for debugging functions and Angular. So I'm going to click on that one, and I'm going to press Run with the green button. And now it's going to run a couple different things at the bottom. It's going to make sure Azure Functions is set up on your machine, so it's opening a terminal to do that. It's got a really cool ASCII art setting that up. It sets up my routes, and then in another window, it's setting up the Angular build process. So if you look down here, you'll see there's 4 tasks open. It actually opens some of those to build this app, and then the app loads up here. And once again, in the debugger, we can see that I've got launch Angular, and I've got my functions. So if I go back and I go to my breakpoints, oops, and I enable them, which I'm doing by hitting this button right here. Now I go back to my app, and I refresh. I'm debugging in Angular. And now, just to prove it's happening, I'm actually debugging right there in my function app for my code. So all this allowed me to set up my presentation API running in functions. What's the other half, though? The other half is making sure my code runs in storage, so I can actually browse to that application. So Angular, as we all know, I'm going to turn off the debugger, and we'll kill those. As we all know, Angular has a dist folder, and inside your dist folder, you have all of your assets that you're going to deploy. Mine's called Heroes Angular, and then you can see all the build assets down here, including my index.html. So I did that ahead of time just to make sure we're ahead of the game. All I have to do to deploy this to the cloud is I can right-click, and I can choose Deploy to Static Website right there. Another way to do that is to come over to this Azure extension for storage, and notice I've got one here called AngularConnect. I created a storage account. That took me about a minute to actually create, so I did that in advance. You just have to press the button here to create one. And then once I created that, you'll notice you upload it, and it puts those same assets up inside the storage account. So you can also hit this button here to redeploy it. So if I make changes, when I press redeploy, it's going to ask you where do you want to go, what folder do you want to look inside of. Again, you can do it from over here. You can right-click on the heroes, deploy to static website. Again, choose this one here. Now notice what it's warning me about. It says the storage container already contains 21 files. If you deploy what's on your machine, it's going to delete those and put what's on your machine there instead. Are you sure you want to do this? And I'm glad it's there because I've almost done this to the wrong app many times. And then when it's done, they've got it running right here. You can see, and I haven't set up a custom URL yet, but you can see this is the storage site that it hit in the cloud for the Tour Heroes application that we're running. So now we've got the app running in storage, super fast. We've got the web APIs running in functions, super fast, no servers, and all I need is to set up a custom URL of my own. I could set a CDN up if I want to, and maybe set up cores or something to proxy the storage account over to the serverless functions. And we saw how everything works through debugging in VS Code. And this is important to me, because I don't know about you, but when I write code, I make a lot of mistakes. And when I make mistakes, I like to go through them and figure out what's actually happening. I don't write it right the first time. So you can debug your functions code locally. You can debug your Express code locally. You can debug your Docker code if that's the way you go locally as well. And then you can take front-end JavaScript like Angular, and you can debug that alongside your Node Express or Functions app at the same time inside VS Code. So today, I hope you rethink how some of these apps are being built and some of the ways you're deploying them, and some of the ways you're building them to be able to toggle back and forth to kind of figure out what's the right scenario for you. There is no one scenario. It's choose the right tool for the right job. So challenging our assumptions, 3 main tips that I'd like to leave you with. Consider the presentation API. Maybe there's a better word for this out there somewhere, but basically it's another API server that can straddle, if you have that problem, all the different APIs that you have to talk to. Consider creating one of those, consider creating a storage account and using serverless with it. You can create your serverless functions, you can create your storage account, and then tie the two together to build your Angular app and deploy it to the cloud. If you need more full control over your servers, absolutely build your own server and deploy it to the cloud using Docker or loose files. That's another option that you can do. And it's absolutely fine either way. You've got to weigh the balance between the cost, and I don't just mean money, but the cost of your time, the resources, and the effort for building both types of solutions. And as promised, if you have any questions on any of this, you can walk through exactly what I did. There's a static site tutorial up at this link here. And I'll post this up on Twitter later too, so you don't have to worry too much about taking photos. Static site tutorial will walk you through creating a static site from scratch and deploying, I believe it's a React app, forgive me, that deploys the cloud, but you can deploy any app that you'd like. A serverless tutorial lets you build a serverless function from scratch and then take that function and also deploy it to the cloud. If you want to use all the cool extensions that I had, this AZ Tools extension will give you the Docker extension, the storage extension, the functions extension. It's excellent, and it works really well inside of VS Code. If you want to try pushing it to the cloud, there's a free link right here. You can sign up to get Azure for free. And if you want to learn how to do the Express app over to Functions, because I kind of made that a side note, where you can build an Express app and then move and migrate that to Functions. I wrote an article on how to do this. You can find it at that link. And then, of course, all the code that I showed you can get from this link right here. Sorry for all the links, but it was a lot of content, and I hope you have a great conference and that you challenge your assumptions this week. Thanks for coming.